welcome to lecture number 19, NPTEL online certification course on bioreactors. In the previous lecture, we had assigned a problem, practice problem 5.1. Let us solve that in this lecture. The problem read, let us consider the same stoichiometry as earlier, that we considered in the lecture. CHMOL plus ANH3 plus BO2 giving you YX CHPON NQ plus YPCHROSNT plus CH2O plus DCO2. These are the stoichiometric coefficients A, B, YX, YP, C and D. Estimate the cell oxygen yield coefficient YX/O defined as the ratio of the amount of cells produced to the amount of oxygen consumed in terms of the relevant parameters among gamma S, gamma X, gamma P, epsilon, eta and xi. Assume that the mass fraction of carbon in cells is 0.5. Let us look at the solution. What is needed? Our usual first question. YXO in terms of the various quantities that we have defined is what we need. What is known or given? The stoichiometric equation is known. The mass fraction of carbon in biomass is 0.5, that is known. And how do we connect what is needed to what is given? We know that YX/O2 yield of cells with respect to oxygen by definition is mass of cells or biomass produced divided by the mass of oxygen that is consumed. From the stoichiometric equation, the biomass produced contains YX moles of C or 12 YX grams of C. Let us see this stoichiometric equation again. This is our biomass here. This is Yx is the stoichiometric coefficient and C has a subscript of 1, right? For this has been properly normalized for a mole of C and Yx moles are formed. Therefore, this particular stoichiometry gives Yx moles of C, and we know that if we multiply moles by the molecular mass, we get grams, and therefore Yx moles of C or 12 times Yx grams of C. If the mass fraction of carbon in biomass is 0.5, that is what we have been asked to assume in this problem, the biomass produced is 12 Yx by 0.5. This is unitary method. It might appear a little odd in the beginning, but it's just unitary method. The mass fraction is 0.5. If 1 contains 0.5, how much will 12 Yx contain? Or in other words, if 0.5 C in biomass corresponds to 1 biomass, 0.5 C corresponds to 1 biomass, how much would 12 Yx grams of C correspond to? What is the biomass it will correspond to? That will be 12 Yx by 0.5. 0.5 of 12 Yx, if 0.5 is 12 Yx, what is 1? Okay, that's the unitary method that we use to get this particular expression here. Just go ahead and practice this. It might appear a little odd in the beginning, but it is just unitary method. From the above shown stoichiometric equation that we saw earlier, the oxygen requirement for every mole of substrate is B moles. Okay. We saw that equation. Let's just see it again. You have B moles for every mole of the substrate here. So oxygen requirement for every mole of the substrate is B moles, and the molecular mass of oxygen is 32, and therefore 32 B grams is what is the mass of oxygen that is required here. We are converting everything into mass because the yield coefficient is defined in terms of masses. Therefore, the yield of cells with respect to substrate, the mass of cells is 12 yx by 0.5, and the mass of oxygen is 32 b yxO2. YxO is some representation that I've used earlier. For the purposes of this problem, let us say O and O2 refer to the same molecular oxygen. So let there not be any confusion regarding that. Yx/O2. B and Yx here are specific for a given stoichiometry, right? So you need to know the actual conditions to be able to estimate these if we talk in terms of B and Yx. But we said that the advantage of this method is that we have thumb rule values for certain quantities, and we can use those thumb rule values to get quick estimates. Okay, those certain quantities for which we have thumb rule values could be gamma S, gamma X, gamma P, right? And the fraction of electrons transferred to oxygen, biomass, or product, that is epsilon, eta, and xi. These are the ones that can be somewhat generalized. We have some thumb rule values that we can quickly use to estimate. We already know that for a variety of cells, gamma X equals 4.2, about 4.2. From our formulation, we know that 4b by gamma S is a fraction of electrons supplied of the substrate supplied to oxygen. This by X, gamma X by gamma S, the fraction of electrons supplied to the biomass, plus Yp, gamma P by gamma S, the fraction of electrons supplied to the product. These fractions must equal 1. Therefore, we had defined 4b by gamma S as epsilon, Yx gamma X by gamma S as eta, and Yp gamma P by gamma S as xi. So, epsilon plus eta plus xi equals 1. This we have already seen. Just repeating this. Thus, Yxs/O2, we have already seen this is mass of cells by mass of oxygen, 12 Yx by 0.5. 12 by 0.5 is 24. Yx from here is nothing but eta gamma S by gamma X. That is what I have done here. Eta gamma S by gamma X has been replaced for Yx, and 32b, b from here is nothing but epsilon gamma S by 4. So epsilon gamma S by 4 has been used for b here, and if we cancel the terms, this is 4 goes there 8 times, 8 goes here 3 times. Well, that comes a little later, I guess. 24, and there is some value that is here. There's some error here. So ultimately, it will. Hold on. This is 24 here. This is eta gamma S by gamma S. This is shown. 32 here. Epsilon gamma S by 4 is shown. 4 times 8 is 32. Yeah, that's what I meant. 4 times 8 is 32. So 24 eta by 8 epsilon gamma X. The gamma S's would get cancelled here. So this is what remains here. And here we have 24 the gamma, this epsilon times gamma X we have here. The epsilon plus eta plus xi equals 1. So we could write epsilon in terms of eta and xi, which are easier parameters to have. Therefore, epsilon has been written in terms of 1 minus eta minus xi. The 8 is superfluous here, so let's get rid of the 8. So 8 goes here, 8 goes in 24 3 times, so 3 eta divided by gamma X from here times epsilon 1 minus eta minus xi. Let's do that right away so that there is no confusion. Yes. So that has been taken care of. 3 times eta, 24 by 8. I guess I forgot to not include that when making this particular slide. The calculations are okay, but just the representation here, there was an error. That's all. Okay, let's get back to wherever we were. 3 eta by gamma x 1 minus eta minus xi. So finally we have gotten the yield coefficient of cells with respect to oxygen as 3 eta divided by gamma x 1 minus eta minus xi. So in terms of all the generalized parameters for which we have some thumb rule numbers. Therefore, oxygen uptake rates can be estimated from biomass formation data. We already know gamma x, eta and xi. You can look into the literature to find some estimates, and those estimates can be used. Okay. With that, we come to the end of this lecture. When we meet in the next lecture, we will take module 5 forward. See you then.